Okay, for this problem, we're told to write down a Taylor polynomial with degree 2 centered at a equals 1. So what that means is to do t sub 2 of x centered at a equals 1, which in general the formula is going to be f of 1 plus f prime of 1 x minus 1 plus f double prime of 1 over 2 x minus 1 squared. Right? That's the formula for the degree 2 Taylor polynomial centered at 1. Okay. Now for our particular function, we're dealing with f of x equals x to the negative 1 half. So I need to find f prime and f double prime. And I need to plug in 1 into those functions. So let's see, well, plugging 1 into those functions is very easy. It's just going to, because x to any power is 1. So actually, let's just go ahead and write down what t sub 2 of x is. So f of 1 is right here. That'd be plugging 1 in here. That's 1. F prime of 1 is going to be negative 1 half. F double prime of 1 is going to be 3/4. So when you simplify this, this is 1 minus a half x minus 1 plus 3/8 x minus 1 squared. That is the degree 2 Taylor polynomial centered at a equals 1 for this function. Okay. So we know that f of x is approximately t sub 2 of x. Taylor's inequality says that the error is less than m over n plus 1 factorial x minus a to the n plus 1. Okay. Okay. Now n is 2, so that means n plus 1 is 3. A was 1. Okay, so here is an upper bound for our error. We need to find a suitable m. Okay. Now for m, we need the third derivative, and we need to graph it between x and a. Okay. The third derivative of this function, I just take the derivative of this, that would be negative 15 over 8 x to the negative 7 halves. Okay. And I'm supposed to graph that between x and a. Well, I know a is 1, and my x values, I'm told, are going to be somewhere between 0.7 and 1.3. So actually, all I know is that x is somewhere in here. Right, maybe x is there. Okay. Now, I'm supposed to graph the absolute value of this function, which is going to turn that into a positive, and it is x to a negative power, so it's going to be a decreasing function. Right, this is what the graph of the absolute value of the third derivative looks like. It's going to be 15 over 8 x to the negative 7 halves. And we need to choose an m that is always bigger than that function. Okay. Now the worst case scenario is x would be 0.7 because that's where this function is the highest. So I got to choose an m value that is bigger than that function value at 0.7. Let's see, what is that? Okay, that'd be 15 over 8 times 0.7 to the negative 7 halves power is 6.5 something. So let's make it 6.6. Just to, so I'll round it up just to simplify things a little bit. Okay. So my m value, I can choose that to be 6.6. So 6.6 over 3 factorial. Now, what else here? X minus 1. Well, keep in mind x is somewhere between 0.7 and 1.3. So x is always within 0.3 of 1. So really x minus 1 is always less than 0.3. So really I could say this is less than, and yeah, the very biggest this difference could possibly be is 0.3. There. Now I just figure out what that is. Okay, so I do 6.6 over 3 factorial times 0.6 to the third power, 0.3 to the third power. I get 0.0297. I could even round that up a little bit just to simplify. I'll say 0.03. Okay, so my error in that approximation for those x values is guaranteed to be less than 0.03.